करना होगा. Now, so what we have done, we have just solved the 3 triatomic molecule, and that is linear one. Let's go for some more problem based on all whatever we have done. So now we will do it very fastly, and in general, we will just try to find the normal frequency, and I will just give you as a homework that you can find the normal modes with yourself. Okay, because finding the normal modes is just finding the eigenvector of a matrix. Okay, so just you can do practice with yourself and just post me on your group. Okay, so let's try to go for a normal next problem, and this is very interesting problem. So this is rigid support. There is a first spring and one mass, second spring, another mass, and again this is a rigid support. Okay, and this is mass m, this is mass m, this is k, this is k, this is k. So 3 spring, 2 mass system, they are linearly attached to each other. So now just tell me, what will be degree of freedom? What will be degree of freedom?
The motion along
Only along x-axis.
2 degree of freedom.
2 degree of freedom. Very good. So that will be 2 cross 2 matrix. So this is very simple. So now let's go for this particular variation. This is my first one, and this is my second one. Okay, and these 2 supports are rigid. So now just write the potential energy. So half, and this is the spring. So here, due to first particle, there is elongation or contraction. Due to first particle, there is elongation or contraction.
Elongation.
Elongation. Eta 1. Is that any contraction from this rigid support?
No, sir.
No. That means -0 whole square, and k will be also there. Now just tell me, what about the second one? What about second spring?
Eta 2.
Eta 2
Eta 1.
minus eta 1, है ना? Whole square. Elongation due to second one and compression due to first one. Now just tell me, what about third one, third spring?
Minus eta 2.
Very good. Minus eta 2 whole square. And now you have to write your matrix, and that matrix is half 2 times eta 1 square plus 2 times eta 2 square minus 2 times eta 1 eta 2. What is my next step? What is my next step? Make it symmetric matrix. So when we are making it symmetric matrix, half 2 times eta 1 square, this is diagonal. This is also diagonal, but this I can write eta 1 eta 2 minus eta 2 eta 1. Now, and that is k will be also there. What will be your V matrix? बताओ फटाफट. 1 1 1 1 क्या होगा?
K, sir.
फिर से सोचकर बताओ.
2K.
What is
2K.
V is equal to half Vij eta I eta j. What is Vij? Is the coefficient of half eta I eta j, isn't it? So what is this value? That value is 2k. Now eta 1 eta 2. Minus k. Eta 1 eta 2 is this one. This is eta 2 eta 1. In a matrix form, this is different element. So this will be minus k. Obviously it is symmetric, and then it is also 2k. Okay. So what will be my kinetic energy? My kinetic energy is half m eta 1 dot square plus half m eta 2 dot square. And now you can easily write your kinetic energy matrix. बताइए क्या होगा? m 0 0 m, है ना? What is kinetic energy matrix? The kinetic energy matrix is half Tij eta I dot eta j dot. So this is your kinetic energy matrix. Okay. चलो नेक्स्ट वन आगे बढ़े. नेक्स्ट हमें क्या करना होगा? You have to solve the secular equation. So when you will solve the secular equation, V minus omega square T must be equal to 0. So you have 2K minus omega square M whole square. Sorry. So you have to just go for 2K minus omega square M minus K minus K. 2K minus omega square M must be equal to 0. And you can easily find 2K minus omega square M minus K square must be 0. You can use A square minus B square formula and easily you will have 3K minus omega square M into K minus omega square M must be equal to 0. So omega is equal to root under K upon M and omega is equal to root under 3K upon M. So what is your fundamental frequency? What is your fundamental frequency?
Root K upon M.
Very good. What is your first overtone? Root under 3K upon M. So now you can find the normal modes and I am just giving you your normal modes. 1 by root 2M, 1 for omega is equal to root under K upon M and x2 is equal to 1 upon 2M, 1 minus 1 for omega is equal to root 3K upon M. Just check it whether you are getting this thing or not. Okay. आप solve कर लोगे. This is your homework. Okay. Just try to do you with yourself. Because I have solved all thing है ना. मैंने काफी solve कर दिया आपके लिए. चलो, let's go for third one. Everyone is comfortable? चलिए. Let's go for this problem. This is very interesting. So there is a circle, a ring, and there is a one particle of mass m, another particle of, and you can elongate something like this. This is your mass m, and you have third particle of mass m, and you have all this spring. So this is your mass m, mass m, mass m. Okay, and all spring is your k. The spring constant is k, and this particle is constrained to move on a circle, okay, of some radius a. So this can be moved something like this. So you have to write potential energy matrix, you have to write kinetic energy matrix, and then you have to find the normal frequency. Okay, so this is your triatomic molecule. This is third. So I am writing this one is first one, this one is second one, this one is third one, and I am just displacing it in a very normal way. So this is my way to displace. Okay, chaliye. So write the potential energy. So this is your first spring. So due to first one, there is compression or elongation. Just look at the arrow.
Compression.
Compression. And due to second one, this in this spring, elongation or compression?
Elongation.
Elongation. So V
Eta
matrix is equal to, चलिए बताइए क्या होगा? Half K eta 2 minus eta 1 whole square. Okay. Plus half second spring. So this is your first spring. Okay. This is your second spring and this is your third spring. Okay, स्प्रिंग के लिए एस दे देता हूं, ठीक है। चलो, फॉर द सेकेंड स्प्रिंग एलोंगेशन ड्यू टू
eta 3,
eta 3, compression due to
eta 2,
eta 2 whole square. Last one,
okay, eta 1 minus eta 1 minus eta 3,
eta 1 minus eta 3 whole square.
okay.
You can open it. When you will open it, what you will write? You will write half k 2 times eta 1 square 2 times eta 2 square plus 2 times eta 3 square minus 2 times eta 1 eta 2 minus 2 times eta 2 eta 3 minus 2 times eta 1 eta 3. So what is your next step?
Make symmetric.
Make symmetric. So how you will make it symmetric? किसे देखना है आपको symmetric के लिए? I am writing it here.
Vij term.
So I am just removing this thing ताकि मैं इसका space use कर लूं. Okay, leave it. This figure. Now we can do it with mathematics. चलो, V is equal to half K. This one is okay, है ना? ये तो सही है because it diagonal matrix. Second is also diagonal. Third is also diagonal. Now, this is diagonal or off diagonal?
Off diagonal.
Off diagonal. That means eta 1, eta 2 minus eta 2, eta 1. Second, next one. Diagonal or off diagonal?
Off diagonal.
Off diagonal. What is this? Eta 2, eta 3 minus eta 3, eta 2. Next one. Minus eta 1, eta 3 minus eta 3, eta 1. Okay. Now, what is my V matrix? Just tell me. What is my V matrix? First term, 1, 1, 2K. 1, 2.
Minus K.
Very good. 1, 3.
Minus K.
Very good. 2, 1.
2, 1. Minus K.
Okay. 2, 2.
2, 2. 2K.
Very good. 2, 3.
Minus K.
Very good. Minus K, 2K. Okay. That's very simple. Now, what is my kinetic energy matrix? Half m eta 1 dot square, eta 2 dot square plus eta 3 dot square. And what is your kinetic energy matrix? Your kinetic energy matrix will be, बताइए, what will be your first term? M 0 0 0 m 0 0 0 m. So this is again diagonal. आज हम दो ही सारे मैट्रिक्स कर रहे हैं जिसमें kinetic energy diagonal हो. Okay? Good. So let's go for next one. Then we will go for what? Secular equation. Very good. So we will remove all this thing. देख रहे हो कितना fast हो जा रहा है अब, है ना? Once you will do one problem in a very nice manner, then everything is cakewalk for you. Now, V minus omega square t must be equal to 0. So you have 2k minus omega square m minus k minus k minus k 2k minus omega square m minus k minus k minus k 2k minus omega square m must be equal to 0. So now let's go for some determinant. It's a very clumsy. अगर आप इसको just यहीं से open करोगे, it will take a lot of time. So you have to use your mathematical acumen. तो अपने mathematical acumen को use कीजिए. What I will do? C1 is equal to, sorry, this is column. Yes, C1 plus C2 plus C3. What you will get? बताओ क्या होगा? Everyone?
Minus omega square m.
Very good. Minus omega square m minus k minus k. This one is also
minus
minus
K.
omega square m. You can add it.
Yes,
So
sir.
this minus and this will be cancel out. So you have 2k minus omega square m minus k minus omega square m minus k 2k minus omega square m. What will be next step? What should be next step? R2 minus R1. We are doing operation R3 minus R1. Okay. Chalo. What will be next one? बताइए क्या होगा?
Minus omega square m.
Minus omega square m
Minus K.
minus k 0. This value is 3k minus omega square m, isn't it?
Yes,
That will
sir.
be subtracted. So 3k.
Yes,
That
3.
value is 0, 0, 0. 3k minus omega square m. That must be equal to 0. And from here, omega is equal to 0. And omega is equal to 3k by m. And omega is equal to what? 3k by m. So this is degenerate or non-degenerate?
Degenerate.
Degenerate. Why degeneracy is there?
It has omega has the 2 values.
Obviously, but what is in physics? Physics में क्या problem थी जिसके कारण degeneracy हुआ? चीजों को देखो.
Circular part.
Circular thing. You can change 1 to 2, 2 to 3. मैट्रिक्स में कोई भी चेंज नहीं आ रहा है ना? And you can see linear triatomic molecule. उसमें कौन सा टर्म 0 था जरा देखो तो.
First.
1 3 and 3 1 term was 0, isn't it?
Yes, sir.
But here you have also 1 3 and 3 1 is going to attach. So there is interaction between 1 and 3 also, isn't it?
Yes, sir.
है ना? So why you have this degeneracy into picture? Okay. So this is your degenerate eigenvalue. So this is wonderful problem. Any doubt? Everyone is comfortable? चलो.
Yes, sir.
हमारी क्लास कितने बजे तक है? 7:15 तक है ना?
7:10.
Okay, 7:10. Okay, I have 10 minutes, so I will use it. Good. Let's go for one more. Now, this was in your GATE exam. Very simple, but interesting to solve. Okay, so this is your diatomic molecule, but linearly diatomic molecule. And this support is rigid. So now, let's write the potential energy matrix. What is your potential energy matrix? बताइए, for the first spring.
Eta.
Half k, so write it 1, write it 2, make it elongate something like this. So what will happen? Half eta 1 square. For the second spring,
Eta 2 minus eta 1.
half eta 2 minus eta 1 whole square. So again, you will open up and that value is half k eta 1 square, half k eta 2 square, eta 1 square minus 2 times eta 1 eta 2. What is the next step? What is the next step?
Matrix.
Make it symmetric. उसके बगैर गलत हो जाएगा, है ना? eta 2 square plus eta 1 square minus eta 1 eta 2 minus eta 2 eta 1. Okay. Now write the potential energy matrix. Eta 1 eta sorry, eta 1 square. What is your coefficient of 1 1?
2k.
2k. Very good. 1 is here, so you can write it in this form, half 2k eta 1 square, isn't it? कभी भी half हटाना मत. Half k eta 2 square minus half k eta 1 eta 2 minus half k eta 2 eta 1. This half is very important. Never write k eta 1 square. Are you getting my point? आप ये कैंसिल मत कर देना एग्जाम में, अदरवाइज दिक्कत हो जाएगी. चलिए, व्हाट विल बी नेक्स्ट वन बताइए. दिस वन इज 2k 1 2
Minus k.
minus k 2 1
Minus k.
2 2.
And k.
Very good. So this is your potential energy matrix. Let's try to go for kinetic energy matrix. So when you will go for kinetic energy matrix, this is very simple. Linear है तो कोई problem नहीं है. Eta 1 square plus half m eta 2 square. Okay? And when you have this particular problem, then you have basically kinetic energy matrix is m 0 0 m. Okay? So you can just write this one. Clear here? So now you can go for secular equation. V minus omega square t must be equal to 0. And you can solve 2k minus omega square m minus k 2k minus omega square m must be equal to 0. Okay?
Sir, k minus omega square.
Sorry, k minus omega square m. Okay? So just try to solve it. I am just giving you as a homework. Solve कर पाओगे? Just try to solve it. ठीक है? Okay. So this is from my side of a basic problem of a small oscillation. ठीक है? Now एक हम लोग और क्लास लेंगे जिसमें थोड़ा नेक्स्ट लेवल के प्रॉब्लम को सॉल्व करने की कोशिश करेंगे. ठीक है? ओके? तब तक आप लोग इस तरह के प्रॉब्लम को प्रैक्टिस कीजिए. एंड देन I will give you one problem homework, and next day I will solve it that problem. Okay? Are you getting my point? Every day I will give you one problem homework, and next day I will solve it that problem. Again I will give you one problem homework, next day I will solve the problem. Okay? So एक क्लास के बाद हम लोग 2-3 दिन इस तरह से प्रॉब्लम को सॉल्व करेंगे, जिससे आप एवरीडे एटलीस्ट वन प्रॉब्लम इसके सॉल्व कर पाओ. ओके? बिकॉज दे ऑल आर रियली टफ प्रॉब्लम, एंड आजकल जो एग्जाम में जैसे प्रॉब्लम आ रहे हैं उस तरह के प्रॉब्लम, मेनली TIFR और जेस्ट के प्रॉब्लम को हम लोग देखने की कोशिश करेंगे. ठीक है? चलो आज के लिए इतना ही. थैंक यू.